In the early 2000s, researchers were running what seemed like a routine experiment. They were injecting electrons into semiconductors at a tiny point of contact called a quantum point contact. Based on decades of theory, they expected these electrons to spread as waves through the semiconductor. Instead, when they imaged where the electrons actually went, they saw something completely unexpected. The electrons organized themselves into long branching filaments, even though there were no channels in the material guiding them. When researchers saw this data, it quickly became clear that this was a new type of transport phenomenon that previously had not been documented. This phenomenon is called branched flow. In this video, I'm going to show you how it works and why it shows up on scales as small as the quantum realm with electron waves, up to world-sized scales and tsunami waves crossing the ocean, and even on intergalactic scales where energy is focused and branches by random variations in the universe. One way to see this branched flow in real life is to make a soap bubble. The surface of the bubble looks pretty uniform, but it's not actually. There are locations on the bubble that are slightly thicker and thinner than other areas. Because of this, light caught in the middle of the bubble's water layer will reflect inside that layer. But since some places are thicker than others, the light has to zigzag longer distances in some regions than others. So the thickness of the bubble slows down the effective wave propagation of the light, similar to how a change in density affects waves. This gives us the exact conditions we need to see branched flow. So now if I just take my green laser pointer and shine the light right into the middle of that bubble film, let's check what we see. Whoa, look at that. I can totally see the branches forming. The branch patterns are continually shifting and changing because the locations of those thick and thin spots on the bubble are changing and flowing with air currents. This phenomenon that I'm showing here was first seen with light using the same method only in 2020 when it was published in the journal Nature. It's amazing to me that we're still finding phenomena like this that were hiding in plain sight. Once branched flow was discovered, we started finding it everywhere. For example, in 2011, tsunami researchers were surprised to find that tsunami wave energy formed branching patterns as it traveled across the ocean. And it became clear that these branches were examples of branched flow, caused by smooth random variations in ocean depth. Branched flow is an amazing phenomenon that appears wherever waves travel through a medium with small smooth variations in density or speed, especially when those variations occur on length scales larger than the wavelength.